Now let us discuss one more question related to the AC. The question is something like this. You have a 50 microfarad capacitor, 50 microfarad capacitor, then you have a 30 ohms resistor, then you have a 0.7 Henry inductor, all in series. So this is 50 microfarad, this is 30 ohms, and the other one is 0.7 Henry inductor, all connected in series to an AC voltage of V equals 300 sine 200t volt. Question is calculate the peak value of current. Calculate peak value of current. Now see, the inductor is there, capacitor is there, the resistor is there, applied voltage is 300 sine 200t times V, 200t volt. You have to find the current. See, if only resistor were present, then you can simply divide this voltage by the resistance value and you will get the current. But this situation is different. You have three different elements, current elements, capacitor is there, the inductor is there, the resistor is there. So all will be providing different values for their resistance, and the final value will be different from the individual value. So for example, if you take the case of capacitor, the resistance which the capacitor offers, you call it as the capacitive reactance, denoted by the letter Xc, and it is equal to 1 by C omega. Similarly, if you go for the inductor, the resistance which it offers, you call it as inductive reactance, and it is equal to XL, which is equal to L omega, and already resistance is present there. Now since they have been applied across an AC, each will behave differently for an AC voltage. For example, so before coming back to the question, let us see how it behaves. If you apply an AC to an purely resistive circuit, so you have only the resistor and you are applying an AC, V is equal to V0 sine omega t to a purely resistive circuit, the current and the voltage will be in phase. Once the current passes through the resistor, both will be in phase. Means there won't be any phase lag or phase lead between the voltage and the current. So how do you represent it? So you represent it by equation and also by the phasor diagram. So when you represent it by equation, you write it as V is equal to V0 sine omega t and I equal to I0 sine omega t, because both are in phase. Now what is a phasor diagram? Phasor diagram is something which is used to represent two sinusoidally varying quantities having the same frequency but different phase. So when you represent it using the phasor diagram, so you represent it like this. Let this be V0, which is making an angle of omega t with the reference line, and since you have applied the AC across the resistor, both are in phase, so you also represent the I0 value, that is the peak value of current, also along the same line. And when you plot it across the y-axis, you get instantaneous values of V and instantaneous values of current. So y-axis actually represent the instantaneous values of current and instantaneous values of voltage. So this is the phasor diagram for when the AC is applied for a resistor. So both are in phase. But it is different when you take the case of a capacitor or an inductor. So for a capacitor, you apply a voltage equal to V is equal to V0 sine omega t. In case of the capacitor, the current leads the voltage by an angle of pi by 2. So the equation comes like this: I is equal to I0 sine omega t plus pi by 2. Now how do you represent it in the phasor diagram? You represent it something like this. This is the applied voltage V0, which is making an angle of omega t, and this gives its instantaneous value of V, and current is leading the voltage by an angle of 90 degrees. So you will represent it somewhere here. This is your I0 and you plot it back to the y-axis to get the I. Now this angle should be equal to 90 degree. Similarly, when you apply, so current leads the voltage by an angle of 90 degree in case of a capacitive circuit. Now similarly, if you take the case of an inductor, you apply the voltage V is equal to V0 sine omega t across the inductor. Because of the back EMF, the current lags behind the voltage by an angle of pi by 2. So you write it as I0 equal, I equals I0 sine omega t minus pi by 2. So how do you represent? This is reference line. You have V0, current is lagging by 90 degree. So actually the phasor diagram is turning anti-clockwise direction. So this will be omega t minus pi by 2, so it will be something like that. This will here will be the I0 value, and you have I instantaneous values. This is V. So normally they will ask, sometimes they will ask about the phasor diagram also. Now coming back to the question, since the voltage and current are not in phase, so you cannot use that V by I equal to R as per Ohm's law, because other elements are also present. So what you have to find out, you have to find out the net impedance provided by the circuit. And as we have learned from the phasor diagram, in case of the capacitor, the current is leading. In case of the inductor, the current is lagging. So the impedance equation for an LCR circuit in series is Z equals root of R squared plus XL minus XC the whole square. If the circuit is, see this XL minus XC is an assumption that the circuit is behaving more as an inductive circuit compared to the capacitive. If it was having a more capacitive nature, then it will be XC minus XL. In this particular case, we believe that it is more like an inductive circuit. So now XL, as we have already discussed, XL is equal to L omega. See, only L value is given here. L value is given as 0.7 Henry. How much is omega? So that omega you have to find from the applied voltage, because applied voltage is given as 300 sine 200 t. So in place of omega t, it is 200 t. So you have omega equals 200. Now XL will be equal to L times omega, means it will be equal to L is 0.7. So 0.7 times 200, that will be equal to the XL value. Similarly, XC value will be equal to 1 by C omega. How much is C? C is 150 microfarad. So it will be equal to 1 by 50 micro means 10 raised to minus 6 times omega is 200. So this much will be the value for the XC. So you have XL and you have XC and you have the R value. So once you get this, once you substitute all these things, you get Z value equal to 50 ohms. When you substitute XL, XC value in this particular equation, you will get Z value equals to 50 ohms. Now to find the peak value of the current, I equals V by Z, you have to do V0 by Z. So what is I peak value? So I0 is what you have to find, so you have to do by V0 by Z. V0 from the equation it is 300, applied voltage 300 divided by Z 50, so it will be equal to 6 amperes. So this is how you have to solve, because this is not a direct resistive circuit. Capacitor is given, inductor is given, applied voltage is given, and you have been asked to find the peak current. Unless you find out XL, then XC and the Z value, you won't be able to solve this question. Now another general question related to this will be, how do this XL and XC varies with frequency normally? Or they will ask you to draw the graph between XL and XC, XL and frequency. See, XL is equal to L omega. Omega is L times 2 pi f. means if f increases, xl will also increase. If you draw a graph, this is on xl, this is frequency, f increases, xl also increases, you will have a straight line for it. But if you have used the same logic for capacitor, xc is equal to 1 by c omega, so 1 by c times 2 pi f. So if f increases, xc has to decrease, and it is not linear decrease, it is a curve. So this graph will be like this, xc and frequency. So this is normal question related to this xl and xc. Hope you understood.